Hi, here in this set we are given that there are 9 boxes arranged in a 3 by 3 array as shown in the tables 1 and 2. So these are 3 rows, these are 3 columns. Each box contains 3 sacks. So there are total 9 boxes, each box contains 3 sacks. So we will have total 9 into 3, 27 sacks. And each sack has a certain number of coins between 1 and 9, both inclusive. The average number of coins per sack in the boxes are all distinct integers. So average number of coins in all these 9 boxes is a distinct integer. And since we know that the number of coins in a sack can be 1 to 9, so the averages will be between 1 and 9 only. Average cannot be less than 1, it cannot be greater than 9. So we want 9 distinct averages for these boxes. So these distinct averages will be 1, 2, 3, 4, so on till 8 and 9. Fine? Cool. The total number of coins in each row is the same and the total number of coins in each column is the same. So total coins in this row will be same as total coins in this row and same as total coins in this row. Similarly, total coins in this column will be same as total coins in this column and in this column as well. Fine. Now table 1, this is table 1, this is table 2. Table 1 gives the information regarding the median of the number of coins in the 3 sacks in a box for some of the boxes. So for example, in this box, the median number of coins in a sack is 2. So there are 3 sacks, right? There are 3 sacks. So the first sack or the least number of a sack will have least number of coins, a sack will have highest number of coins, and then you'll have a median value. So the median value here is 2. Out of the 3 sacks, once you arrange the 3 sacks in this box in increasing order, the middle sack will have 2 coins. Again here the middle sack will have 8 coins. Here the middle sack will have 9 coins, and here the middle sack will have 6 coins. So we know the median for only these 4 boxes, not the other 5 boxes. Fine. Next is in table 2, each box has a number which represents the number of sacks in that box having more than 5 coins. So for example, this box has only one sack containing more than 5 coins. So more than 5 means 6, 7, 8 or 9. Here also there is only one sack containing more than 5 coins. So if there is only one sack containing more than 5 coins, that means the remaining 2 sack will have 5 or less than 5 coins, right? There is one sack having more than 5 coins in this box, so the other 2 will have either 5 or less than 5. In this box, all the 3 sacks contain more than 5 coins. In this box, none of the 3 sacks contain more than 5 coins. Okay? So this is the information as far as number in this table is concerned. And then that number is followed by a asterisk if the sacks in that box satisfy exactly one among the following 3 conditions. These are the 3 conditions. If a box satisfies exactly one of these 3 conditions, then that particular box has only one asterisk. And if there are 2 asterisks, it means that it will satisfy more than 2 of these conditions. Okay, let's see what are the conditions here. The first condition is that the minimum among the number of coins in the 3 sacks in the box is 1. Okay, of the 3 sacks, the minimum is 1. So of the 3 sacks that will have, the least number of coins will be 1. Here it says the median of the number of coins in the 3 sacks is 1. Okay, so median will be 1. This is the second point. And the third point, the maximum among the number of coins in the 3 sacks in the box is 9. Okay, so the maximum is 9. That's what it is, right? Fine. So the box will have only one asterisk if exactly one of these conditions is met, and the box will have 2 asterisks if 2 of these conditions or 3 of these conditions are met. Okay. Now let's get solving this set. This set was the toughest set in CAT 23 slot 2. Okay. So these are the 9 boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9. Row 1, 2, 3, column 1, 2, 3. Okay. So now we know the medians for 4 boxes. So let's draw these or write down the medians here. So there are 3 sacks here. The middle sack in this box has 2 coins. Here the middle sack has 8 coins. Here the middle sack has 9 coins. And here the middle sack has 6 coins. Okay, fine. Next is, let's look at these numbers: 1, 1, 2, 2, 3, 0, and so on. So here it says there is only one sack which contains more than 5 coins. The number indicates number of sacks containing more than 5 coins. So there is only one sack containing more than 5 coins. Okay, so there are 3 sacks in all these boxes. In this box there is only one sack containing more than 5 coins. Hence that sack would be the sack containing highest number of coins. Okay. Here again there is only one sack containing more than 5 coins, so this will be more than 5. Here the other 2 will be less than equal to 5. Here this is less than equal to 2, this must be less than equal to 5. In this box all the 3 sacks contain more than 5 coins. So this is more than 5, this is more than 5, this is also more than 5. In this box there are 2 sacks containing more than 5 coins. One is 9 and the other must be this one, the highest one. Okay. Here there is no sack containing more than 5 coins. That means all of them must be containing less than or equal to 5 coins. In this box there are 2 sacks containing more than 5 coins, and these 2 sacks will be the highest 2 sacks. So this is more than 5, this is more than 5, that means this is less than equal to 5. And here this will also be less than equal to 5. In this box there are 2 sacks containing more than 5. One is this, other will be this one, the higher one. And the lowest number of coins in a sack must be less than equal to 5 in this particular sack. Similarly, in this box all the 3 contain more than 5 coins. So this is more than 5, more than 5, more than 5. And here none of them contains more than 5 coins. So less than equal to 5, less than equal to 5, less than equal to 5 over here. Okay. Next, let's focus on the asterisks. So there are certain boxes with 2 asterisks and there are certain boxes with 1 asterisk. So let's first focus on those boxes which have 1 asterisk only. Now if there is only 1 asterisk, that means only one of these 3 conditions would be satisfied. Let's first discuss these 3 conditions. The first condition is that the minimum number of coins in a sack is 1. This says that the median number of coins in the sack is 1. Now think about it. If you arrange the sacks in a increasing or decreasing order, and if the median is 1, that means a sack which contains less than equal to 1 will also have 1. The first sack, if you let's say arrange the sacks in increasing order such that this is greater than this is less than equal to the median value, and this median value is less than or equal to the highest value. Okay. Now if the median is 1, this value here cannot be less than 1, so it has to be 1. So if this is true, this should definitely be true. If the second point is true, first point definitely has to be true. So second point alone cannot be the true statement. So wherever you have a single asterisk, that means it satisfies only one condition. That one condition definitely cannot be the second condition. It can be either first condition that the minimum number of coins in a sack is 1, or the third condition that the maximum number of coins is 9. Okay. So let's first focus on those boxes where only one condition is satisfied. Okay. So first is this one. Here only one condition is satisfied. But here we know all the 3 sacks contain more than 5 coins. So obviously 1 cannot be satisfied here. That means only condition 3 must be satisfied here. So the highest number of coins in a sack must be 9. I have arranged all these sacks in increasing order, right? Lowest, then median value, then highest. Next you have only one asterisk here. Now here this value is 9. If this value is 9, the median value itself is 9, then a sack Can it contain more than 9 coins? No. So the only possible value for this sack to contain is 9. So, and there is only one condition that can be satisfied here, and that condition is the third condition. So basically 1 cannot come over here. If 1 comes over here for the lowest coins in this sack, then you'll have 1 and 3 both satisfied, but only one condition can be satisfied over here. Fine. Next, let's come to this box here. In this box, no sack contains more than 5 coins. So obviously condition 3 cannot be satisfied over here, and since only one condition has to be satisfied, condition 2 cannot be satisfied. So in this box 2 and 3 cannot be satisfied. So the only condition that can be satisfied is the first condition. Hence the number of coins in the lowest, or the sack containing the lowest number of coins will contain 1 coin. Okay. Next, coming to a single condition, this box here, this one. Now here it's given that the minimum, only one condition has to be satisfied. This can be 1 and this can be 9. Both are possible over here. So we'll come to this later, right? We'll come to this later. Here all the 3 contain more than 5 coins, and only one of these 3 conditions must be satisfied. So obviously if all of them contain more than 5 coins, 1 and 2 cannot be satisfied. So the only condition that can be satisfied is the third condition. Hence this becomes 9. Okay. Next, let's look at those boxes which have 2 asterisks. Now 2 asterisks means at least 2 or more than 2 conditions are satisfied. Okay. So let's come here. Now at least 2 conditions out of these 3 must be satisfied, or all 3 can be satisfied. So either all 3 can be satisfied or 2 can be satisfied. So let's see, if exactly 2 conditions are satisfied, what can be these 2 conditions? So 1 and 2 can be satisfied. If 2 is satisfied, 1 is automatically satisfied, right? So the conditions that can be satisfied, exactly 2 conditions that can be satisfied are 1 and 2 together, or 1 and 3 also can be satisfied together, 1 and 3. A box can have minimum 1 and maximum 9, that is possible, right? And is it possible to satisfy only 2 and 3 at the same time and not 1? That is not possible. That is not possible, because if 2 is satisfied, 1 is automatically satisfied. So then you'll have 1 getting satisfied automatically. Fine. So if minimum 2 conditions have to be satisfied, it means condition 1 definitely has to be satisfied. There is no other possibility, right? So any box which has 2 asterisks will definitely have a minimum of 1 coin in the sack containing the least coins will have 1 coin. Okay? So this is the box containing 2 coins, and this is the 2 asterisks. This is the box containing 2 asterisks. So this value here must be 1. This value here must be 1, and these are the 2 boxes containing 2 asterisks. So this will be 1, this will be 1. And now along with these 2, let's see what is the other condition that can be satisfied, either with 1, 2 alone, or 3 alone, or all 3 can be satisfied. So let's look at them one by one. Here the second condition cannot be satisfied, right? So if second condition cannot be satisfied with 1 and 2, with 1, 2 cannot be satisfied. So third will have to be satisfied. That means the highest value or the highest number here must be 9. In this box also the median cannot be 1. So the second condition here cannot be satisfied. That means the third condition has to be satisfied. So this must be 9. Okay. Now next, if you look at this box over here, 2 conditions have to be satisfied here. One of them is the first condition. Now here the median cannot be 2 because the middle value has to be highest value cannot be 9 because the sack containing the highest number of coins has to have less than equal to 5 coins. So it cannot have 9 coins. So along with the first condition, second condition must be satisfied here. which is having median as 1. Okay, fine. And for this box we cannot say anything. Either only second can be satisfied, this is less than equal to 5, either only third can be satisfied, or both of them can be satisfied. So we cannot be sure about that so far. So we'll keep this for the later time. Now the other condition or the other requirement that is given is that all these 9 boxes will have a different average number of coins, which is a integer. It's given, right? All these boxes, the average number of coins per sack in the boxes are all distinct integers. Okay, so there will be one box having on an average 1 coin per sack, 2 coins per sack, 3 coins per sack, and so on. So now let us look at which box can have any of these averages. So let's start with the lowest average of 1. Now which box can have the lowest average of 1? Only that box will have the average of 1 where all the 3 sacks will contain 1, 1, 1. Right? That's the only way an average of 1 is possible, isn't it? Cool. So which of the sacks can which box can have all 3 sacks as 1? Here there has to be one sack with greater than 5. Here obviously there are sacks greater than 5. Here you can have all sacks less than equal to 5, that's fine. Here you have a sack which is containing greater than 5, greater than 5, greater than 5, greater than 5 is there. So there are 2 boxes, this box and this box, which contain all sacks which have less than or equal to 5 coins. But if you look at this box we have only one asterisk. One asterisk, that means only one of these conditions can be satisfied. If only one of these conditions that can be satisfied, the only condition that has been already been satisfied is that the lowest number of coins in a sack is 1. So a median of 1 is not possible. So median here cannot be 1. So all sacks containing 1, 1, 1 is not possible for this box. So the only box which can contain all 1 is this 1, 1, 1. Hence the average for this box comes out to be 1. This is the only box which can have an average of 1. So in the corner I will be writing the average 1. So 1 is done. Let's look at 9 now. Which box can contain 9? An average of 9. Now an average of 9 is possible only when all the sacks contain 9, 9, 9 coins, right? Now which box can have all sacks containing 9, 9, 9? Not possible in this column. This is 8 already. Not possible in this in these 2 boxes, and even here 9 is not possible in this sack. So not possible here, not possible here obviously, and not possible here. So the only box which can contain all 3 sacks as 9 is this one. So the average of this box will be 9 definitely. Okay. Now next, so 9 is also done. Next is 2. So let's look at 2. Which box can have an average of 2? An average of 2 means a total of 6 coins in all the 3 sacks combined, right? So 3 sacks, sum of these 3 sacks divided by 3 is going to give us the average as 2. So the total of the 3 sacks must be 6. Let's see which box can have a total of exactly 6. Fine. This itself is 6. So the total here will definitely be greater than 6. So none of these column can have an average of 2. This is 9, so obviously sum will be greater than 6. Here sum is greater than 6. Here sum is greater than 6. And here, even if you take the least value 1 and you take the least value here of 6, the sum becomes greater than 6. So in all these boxes, the sum will definitely be greater than 6. So the only box left now is this box. So the average of this box definitely has to be 2, because no other box can have an average of 2. So if the average here is 2, that means the sum must be 6. So 1 plus this number must be 6. That means the sum of these two numbers, this number and this number, must be 5. Now how is the sum of 5 possible over here? Sum 5 is possible if you have 1, 4 or 2, 3, right? But if you look at it, in this box only one condition has to be satisfied, and that condition is the first condition. So the second condition cannot be satisfied. The median cannot be 1. So the only possible combination here is 2 and 3. The 3 sacks containing coins will have 1 coin, 2 coins and 3 coins respectively. Okay. So average 2 is also done. Now let's look at average 8. Which sack can contain an average of 8? So an average of, or which box can contain an average of 8? If average is 8, the total should be 8 into 3, 24. Now let us look at which box can have a total of 24 here. Fine. Here, even if you assume the highest of 5 and here the highest of 9, the total cannot be 24. So the average cannot be 80 over here. Here obviously the total is not 24. Here the total can be 24. So we have this in our minds. Here the highest value this can take is 5. So 9 plus 9 is 18. 18 plus 5 is 23. So the highest total possible here is 23. So average of 8 is not possible because sum 24 is not possible. Here also, even if you take the highest value of 9, 9, 9, 18 plus 1 is 19. So the total cannot be 24. This is anyways 2. And here also, if you take the highest 5 and highest 9, the total cannot be 24. Right? So the only box where the total can be 24 is this box. So for this box alone, an average of 8 is possible. And this is possible when the sum is 24. So 8 plus 9 is 17 and 24 minus 17 is 7. So this sack here contains 7 coins. Okay. So again the average of 8 is also done. Next is, if you look at this box, for this box we already know all the values 1, 2 and 9. So the total here is 12, and if 12 is the total, average will be 12 by 3, which is 4. So the average here is already known to be 4. Okay. So the average of 4 is also done over here. Cool. Now let us look at this box over here and this box over here. So let's start with this box. Now what are the values possible here? More than 5. So it will be either 6, 7, 8 or 9. Right? So we know since the average has to be an integer, the total should be a multiple of 3. The average here will be some x. So the total will be thrice of x. Hence the total would be a multiple of 3. So let's see, when do we have total multiple of 3? 9 plus 1 is 10. Now 10 plus 6, 16 is not a multiple of 3. 10 plus 7, not a multiple of 3. 10 plus 8, 10 plus 8 is a multiple of 3. So the only multiple of 3 you can get over here is when you have a 8 over here. Okay. So this has to be 8. So the total now comes out to be 18. So if the total is 18, the average will be 18 by 3, which is 6. So the average here will be 6. Okay. Similarly here, we cannot have a 1. So we can either have a 2 or 3 or 4 or 5 less than equal to 5. Again, the total of this should also be a multiple of 3. So we have a 9 plus 9, 18. Now 18 plus 2, 20, not a multiple of 3. 18 plus 3, 21, a multiple of 3. 4 and 5 will also not give a multiple of 3. So the only number that will give you some multiple of 3 is 3 over here. Right? So the sum becomes 18 plus 3, 21, and the average will be 21 by 3, which is 7. So average of 4, 6 and 7 are done. 4, 6, 7 are done. So average of 3 and 5 are remaining over here. Okay? Now, let's look at over here. What is the minimum possible sum over here? The minimum possible sum will be if you have least value here 1 and the least value here, which is 6. So 6 plus 6 is 12 and 12 plus 1 is 13. So the minimum sum possible here is 13. Right? So average of 3 is not possible in this box. For an average of 3, the total should be 12, but the minimum total here is 13. So average of 3 is not possible here. The only possibility will be an average of 5 over here. Right? So the average of 3 must definitely be now for this box. Okay? Fine. So now we just have to calculate these two values. So looking at this box, since the average is 5, the total must be 15. And out of 15, 6 is the middle value. So sum of these two values should be 15 minus 6, 9. So these two together is 9, and we have a single asterisk over here. Single asterisk means exactly one of these conditions must be satisfied. So 2 is not satisfied, so either 1 or 3 must be satisfied. Now for 3 to be satisfied, the highest number must be 9. But if this is 9 and for the sum of these two to be 9, this must be 0, which is not possible. The least number of coins in a sack would be 1. So the third condition cannot be satisfied here. That means the first condition must be satisfied. So this sack here must contain 1, and for the sum to be 9, this must contain 8. Okay? And finally, over here, what you have is total here must be 3 into 3, 9. So the total number of coins must be 9, out of which 1 is already over here. So sum of these two must be 8. And now this box, for this box, two conditions must be satisfied, right? There are two asterisks, so two conditions must be satisfied. Condition 1 is already satisfied. Condition 3 cannot be satisfied because the sum of these two itself is 8. So how can we have a 9 over here? So condition 3 cannot be satisfied. That means condition 2 definitely has to be satisfied over here. That means the median here must be 1. The median is 1, and for the sum to be 8, this must be 7 over here. Okay? So this is the whole arrangement that we have. And if you look at that condition that the number of coins in a row or column must be same, that is also satisfied. The total in this box is 9, the total in this box is 12, the total in this box is 24. Total here is 6, 3, 18, 2, 3, 6, 7, 3, 21, 5, 3, 15, 9, 3, 27, 1, 3, 3. So if you look at column wise, 27 plus 3 is 30, 30 plus 15 is 45, 6 plus 18 is 24, 24 plus 21 is again 45, 24 plus 12 is 36, 36 plus 9 is 45. So in each column we have some same 45. Let's look at row wise. 24 plus 18 is 42, 42 plus 3 is 45, 12 plus 6 is 18, 18 plus 27 is again 45, 9 plus 21 is 30, 30 plus 15 is again 45. So each row also has the same sum 45, right? So this is the set that we have. Now let's look at the questions. The first question here is, what is the total number of coins in all the boxes in third row? So third row, what is the total number of coins? The total number of coins is 45, right? So the answer here is option D, 45. Next, how many boxes have at least one sack containing 9? Okay, at least one sack containing 9 is 1, 2, 3, 4, 5. So there are 5 sacks containing at least 5 boxes containing at least one sack with 9 coins. So option C is the right answer. Next, for how many boxes are the average and the median number of coins contained in the 3 sacks in that box the same? So average and median should be same. So here median is 1, average 3, not same. Average and median not same. Average and median same here. So one box R3 C1 is the first box which has median and average same. Here again different. Here we have same R2 C2. So this is another box. 6, 8 not different. 1, 1 same. So R3 C3 is the third box. Then 9, 9, that means R2 C3 another box. 5, 6 different. So how many boxes have same median and same average? 4 boxes. So the answer here is 4. Okay. Next, coming to next question. How many sacks have exactly one coin? Okay. So how many sacks have exactly one coin? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 sacks which have exactly one coin. So the answer here is 9. And finally, last question. In how many boxes do all the 3 sacks contain different number of coins? So here all the 3 sacks don't contain different. 1, 1 is same. 1 to 9. So this is one sack. 7, 8, 9 another sack. So I'll mark them. 1, 2 all different. 1, 8, 9 all different. 1, 2, 3 all different. 3, 9, 9 not all different. 1, 6, 8 all different, not all different, not all different. So how many sacks contain or how many boxes contain all 3 different sacks? as in all 3 sacks containing different coins? 5. So the answer here is 5. Okay, so that's it for this set. Thank you.